Several applications like robotics, mobility, and surveillance does require a lot of low power, high performance, low latency, and needs to be cost effective, which makes smaller FPGA ideal for running AI inference in real time. But the challenge of implementing AI in FPGA is not a very trivial task. AI models are typically represented in a high-level language like C, and an FPGA needs to be coded in a hardware description language like Verilog. So going through high-level synthesis is typically not very efficient from a resource standpoint, which takes away the power and cost benefit of an FPGA. The solution is Edge AI Builder, which is turnkey machine learning solution for implementing AI on an FPGA. Takes in a C model, optimize it for implementation on FPGA that allow the designer to go through a standard development using FPGA software tools to implement the acceleration. Edge AI Builder takes a CNN model and run it through a series of optimization and quantization to make it efficient for hardware implementation on an FPGA. Then the CNN accelerator core from ComputEra gets configured to run the AI model and ensure it is efficient from a resource utilization standpoint when running on an FPGA. Finally, the CNN compiler generates instruction for this accelerator to run on in order to conduct the inference. To see the ComputEra accelerator in action, take a look at the recent demonstration we did with Efinix FPGA and their Edge SoC framework. Using the intuitive framework, we rapidly were able to deploy our accelerator on their FPGA to classify 1,000 images over 32 frames per second using Tiny Darknet Model. Here is Roger from Efinix, who will walk us through the demo setup on the Efinix T120 Development Board.
The ComputEra demo combines hardware design, that's the part that goes into the FPGA, our Edge Vision System-on-a-Chip framework with the customization, and software design, that's the part that runs in the RISC-V processor. The ComputEra hardware acceleration block is written in Verilog. ComputEra used our Affinity software to compile the RTL for our Tryon FPGA. Affinity is an easy-to-use FPGA tool, and the ComputEra team was able to easily port the existing code to our Tryon FPGA very quickly. ComputEra team appreciated the time enclosure capability of Affinity. Finally, ComputEra uses their quantizer compiler to convert the TensorFlow outputs to something that they can run on the RISC-V and their own accelerator. They currently support a number of AI models and can extend their approach to support more in the future. Now let's take a look at how ComputEra was able to take the basic Edge Vision System-on-a-Chip framework and modify it to build their CNN accelerator engine we showed earlier. They targeted this design for our Tryon T120 BGA324 Development Board. ComputEra is an expert in FPGA and neural networking solutions. Their convolution neural network accelerator, designed specifically for FPGAs, is intended for use for edge applications. This diagram shows the blocks that they swapped out. They inserted their own hardware acceleration block into the vision system on a chip and used DDR DRAM on the development board to hold the raw images, coefficients, and other assorted data. You can see here the whole system is set up. We have the T120 board, a camera, a monitor to display the results, and another monitor to show the images that are going to be analyzed. The RTL design we showed in the previous slide is programmed into the FPGA. The Raspberry Pi camera captures the image on the display monitor. The ComputEra CNN accelerator then analyzes the images, classifies them, and then displays the results on the connected HDMI display. As they went through the development process, ComputEra analyzed actual system interaction to maximize frames per second performance. They had to decide which function was best accelerated in hardware and which would leave in software. The Edge Vision System-on-a-Chip framework gave them the flexibility for those decisions instead of building everything from scratch. Being able to meet those goals in a cost, package size, and power-optimized solution was a very impressive item to ComputEra team, as those are important features to any edge applications. Now that you understand how all this came together, let's take one more look at the demo. The frame rate for the Tiny Darknet model is quite good at over 30 frames per second for the Efinix Tryon device. This is slightly higher performance than that reached with a Zynq UltraScale board. One of the keys, though, is our power differentiation. For other FPGAs, you won't be able to see this level of performance combined with such a low-power solution. Efinix devices are at least a third to half of the power of competing devices, and will be even lower with titanium. If you have a specific model you would like to implement or just an edge challenge that you're trying to solve with a neural network solution, Efinix and ComputEra can help deliver solutions for effective high-performance edge processing at the lowest power, smallest package size, and price for volume production.